Hey everyone, so I have another challenge problem here for you. And here it is. News has just struck the nation that a comet is about to strike the Earth. An underground bunker has been set up with 500 individual rooms. 500 people are selected to be sheltered in this bunker. The 500 people are given a ticket that has their room number on it labeled Room 1 through Room 500. And they will enter the bunker starting with the first person whose ticket says Room 1, followed by the second person whose ticket says Room 2, and so forth until the 500th person enters with the ticket labeled Room 500. The first person decides to ignore the fact that his ticket says Room 1, and he chooses a random room between 1 and 500, but note that he could possibly still choose Room 1. So, after he chooses his room, the next person enters. And if the room marked on their ticket is available, they must choose to enter that room. However, if their room is occupied, they will randomly choose one of the remaining rooms. This process repeats until the 500th person enters. So what is the probability that the 500th person enters room 500? Basically, what is the chance that his room is going to be unoccupied by the time he gets there? So if you want to give this a shot, and I really would love you if you took a stab at this before looking at the answer here, pause the video now and try this out. You might have to reread through this. Okay, so give that a shot. Alright, so if you've tried it out now, you're getting frustrated, or you're just not sure where even to begin with this, here's some helpful hints. Let's think of this on a smaller scale. So let's say in this case that we had only 3 rooms and 3 people in this bunker. 3 rooms, 3 people. Okay. So we have room 1, room 2, and room 3. So let's look at the different cases that we can have here. Case 1. Let's say that the first person who enters chooses, so the first person who enters here chooses to go in the first room. Well, if that's the case, then it's going to go 1, 2, 3. So this is case 1. Okay. And in that case, we're successful. The third person would end up in the third room. Let's try case 2. Say he doesn't choose room 1 randomly. Let's say he chose room 2 in this case. Well, if the first person chose room 2, then this is going to lead to 2 scenarios here. The second person who boards, his ticket was marked for room 2, and now his room is occupied. So he's going to randomly choose a room. So he could choose either room 2 here, or the other thing that could happen here is he could choose room 3. So in case 2 here, if he chose room 2, then obviously the third person has to choose this, so we're successful here. But let's say he had randomly chosen the third room. Well, then the third person has no choice but to choose the first room here. So this will be our third case. In this case, we're not successful. The third person didn't end up in the third room. And then we have one last option here with our rooms. So case 4 here. Let's say the first person didn't choose room 1, didn't choose room 2, but instead chose room 3. Well, then the second person, since his room is available, has to choose room 2. And then, of course, the third person will have to choose the first room here. And in this case, we weren't successful either. But these are only cases. So as you can see, the third person ended up in his room 2 out of the 4 times, which actually is 1/2. Okay? So it worked when we had just 3 rooms. Well, what if we had 4 rooms? So again, let's start with the basic scenario here. Let's say the first person chose the first room. Well, then we'd have 1, 2 would have to choose his room, 3 would have to choose their room, 4 would have to choose their room. So the fourth person ended up in the correct room. And this is the only case. If the first person chooses the first room, this is the only thing we can have, because if their room is available, they must enter it. Now let's say that the first person didn't choose the first room. Let's say he chose the second room. Well, if he chose the second room, we have a few more cases here. If he chooses the second room in this case, that means the second person is going to randomly choose a room. So they could choose this room. If they chose the first room, they could also choose this room. Or if the first person chose that, person 2 could choose that room out there. So if it was the first case scenario here, in this one, if the second person chose the first room, then the third person's room is available, so they must take it, and the fourth person then must take their room, so they end up in the correct room. Now, in this case right here, the third person's room has been occupied. So the third person could take this room, or we'll have this also bounce off here, or if we had 1 and 2, the third person could also take this room out here. So in the top case there, if the third person took that, then the fourth person would have to take this, and again, they end up in their room. In the bottom case, the fourth person would end up in the first spot here, so they're not in their correct room here. Okay, in the case between these two, if the first person chose the second room, second person chose the fourth room, well then in that case, the third person's room is still available, so he has to choose that. And then the fourth person would end up in the first room. So the fourth person does not end up in their room here either. Okay. Well, let's say then the third person, or the first person chose the third room in this case. Well, now the person who chose ticket 2 or has ticket 2 has to take the second room here. And if they take the second room there, now person 3 enters, and that leaves 2 options here. They could take the fourth room, or they could take the first room, and we'd have this. Well, in the first case scenario, that means 4 would have to take the first room. Here, 4 would have to take the last room. And as you can see, this works for this one, does not work for that one. And then finally here, the person who boards or enters the rooms here could choose the fourth room. If that's the case, then the second person will still have to choose the second room. The third person has to choose the third room, which means the fourth person will be stuck choosing the first room, and we aren't successful in that case either. So as you could see, we have a total of 1, 2, 3, 4, 5, 6, 7, 8 cases here. And out of those 8 cases, the fourth person ended up in their room 1, 2, 3, 4 times, which was also 1/2. So you can continue on and test out this theory, but as you can see, this pattern is just going to continue on over and over and over again. So if you were to do this out 500 times, well, the probability is still going to be 1/2. Half the time, the last person who enters this bunker will end up in their room.